All right, hello there. My name is Sean. I'm one of the TAs for this class. And I made a review video like this for my 2110 class, and they seem to like it, so I decided to make one for you guys too. All right, so let's just jump right into it. So the first thing on our list of fun here is print. And print's pretty simple. You just print something, and it comes up in your console. I'm going to be running it in the command line. Don't worry, it's the same thing. But yeah, there you go. Print hello, made hello. Okay. Also concatenate strings within the print statement with a little plus, and usually want to add some kind of space in here or something. So we got a string in quotes here, and then we have plus, and then a string in quotes right there, and then it should print out hello boy. Yep, there we go. Cool. Not only can we add things together, we can also multiply them. So we can have hello with a space 3 times here. So let's see. There we go. Hello, hello, hello. Whoops. Sometimes I will mess this up. Word on quotes too. Single quotes are fine, and double quotes work too, and triple quotes all work. So if we run this, all these should be the same. And yep, all same. Cool. We don't just want to put strings within our print statements. We want to put other things too. And so we can put variables in there. So this is going to say print hello. And then we'll also evaluate little statements in here. So hello times 3 is hello, hello, hello. And then this is going to print 5 because that's what y is. And this is going to print 5 times 3, which is 15. So let's take a look. Yeah, so we have hello, 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 5, and 15. Cool. I'm not sure if you learned this yet, but it's just a little bit of Python trivia, I guess. So the defaults for the ending of a hold on, sorry about that. Yeah, so the default for the ending of a print statement is a new line. So this is going to be hello on 2 lines. So let me show you. Yeah, there you go. But we can also end it with other stuff if you add in this little end equals argument. Like I can end it with nothing, and then it'll just have 2 things right there on the same line. Or I could type in I don't know, like end or something, and yeah, you'll have this end in the middle right there. I'm pretty sure you don't have to know that. So I think that's it for print pretty much. So let's move on to input. So well, what is input? What if I just kind of like throw input right here? What's it going to do? So yeah, so I'm going to run this, and it seems to be waiting on me. So I guess I'm going to type something in. Yeah, so just had me put something in there, and then didn't really do anything with it because it's just kind of floating around here in space. So say we want to put this into something, go like x equals input. So then what we'll do is, well, after that goes in there, we're going to print out this x value. So let's see. Wait for me. I'm going to type in pizza. Oh, and it's spat out pizza. So what happened is I input pizza, and so this became pizza right here. And so x was pizza, and then it printed out pizza. Cool. And as you probably know already from the homeworks, you can put in a little statement like enter pizza flavor. Do you have flavors of pizza? I don't know if that's a right word. Flavor. Okay. Let's run this. Oh, okay. Let's say bacon. Ah, bacon. Cool. All right. You get the point. This is related terminology like prompt. I think that's just saying like if they have a question, it's saying like prompt the user for their favorite types of pizza, like we just did. Yeah, that would be doing this. So yeah, you can also use the word prompt in pseudocode if you want. All right, so the next thing up is int. So what does int do? Well, int converts whatever is in the parentheses to an integer, or it just tries to, and then it fails, as we will see. All right, so let's just try int 5. How does that work? All right, int 5. There we go. All right, and remember, we don't have to just print this out. We can also be like x equals int 5. That works too. See, no errors there. All right, and then so we can also put things that it's going to evaluate here because it's going to evaluate what's inside and then convert it to an int. So because it follows the order of operations there. So yeah, we got 15 right there. Good. All right, and then so what if we try to do a number inside a string right here? That should be fine. So whoops. There we go. Yeah, it works just fine. And then we can also, so what happens when we put a double in here, or a float, sorry, float in here with a decimal. So what's actually going to happen is it's always going to round down. So this is going to be 7 here. So yeah, it doesn't matter if you add 7.1 or 7.9, 7.999. Actually, let's give it a shot. Yep, always going to round down to 7. So yeah. And remember that, sometimes there's some little bugs in the way floats work, so just be careful of that. But don't worry. So then you can also put evaluations with your because it's gonna evaluate this to can't do math in my head, and it's gonna make it into that. So yeah, we got 12. So it got some decimal 12 and rounded down. Okay, so these are the bad ones. So if you put a float inside of a string here, that's not going to work. It says that, yeah, it doesn't like it. So let's see. Also, obviously, if you put something that isn't an integer in here, then, or isn't anything you put in an integer, it's not going to work. So yeah, strings don't work. And then potentially bad is if you have the user enter something in and you can coerce it to an integer. It says, please enter integer. Oh, okay, I'll be good. I'll enter 17. All right, good. There's 17. But what if you have a annoying user that says, please enter integer? You say, I'm going to enter pizza. So like pizza. Oh, no. So your whole program is crashed right there. Yeah, so that's bad. Yeah, you actually have to do this whenever you get input from the user they're going to use math with. Because if you just put if you just get input from the user and say enter a number, and then you try to work with that mathematically, and they don't enter a number, or even if they do enter a number, 5, it's going to give you an error here because this 5 isn't really 5 that they entered in. It's really a string 5 because everything that you input becomes a string. So you have to coerce it to an integer somewhere. So if we just like put int right here, here we go, and then whoops, save this and run it. Yeah, 5, and yeah, that works. So yeah, just make sure to coerce it to an integer at some point if you're going to work with mathematically. This is going to be 5, and 5 minus 20 doesn't make any sense. So those are all the potential ways that int can give you an error that I can think of. There might have been more that you learned in class, so yeah, make sure you look at that too. So I'm actually doing this off the clock, just out of the goodness of my heart. So if I miss something in here, we're actually not responsible for this video. So yeah. So similar to int is str. We're just gonna convert anything inside to a string. So if we put a string in, it's just gonna keep it a string. So this is gonna spit out pizza. Whoops, I cannot type really fast. Okay. And so this is just going to take 5.3 and it's going to convert it to, it's going to make it into 5.3 like this. So yeah, it's good. It's just like printing out 5.3, it's going to print out 5.3. And then you can also like, put anything else in here, like a variable or something. And let's see, that's going to spit out 4. So we should have pizza 5.3 and 4. And whoops, that is the wrong one. Pizza 5.3, 4. Good. It's actually kind of hard to break str. I can even put in print here, and it's gonna use what's called, I think, the toString for print. So it's gonna say, oh, this is just the function we use for print. I can even put a str in there, see what that does. Yeah, it's gonna say this is the str class. So yeah, I guess you could break it if you put like pi 0 in there or something. If you can think of a way that could trip you up, leave it in the comments because I'm not really sure. All right, next up we have float, and it wants you to know what happens when you give it a string, what happens when you give it an integer. So if we give a float, what's going to happen? Should be fine, it's 3.9, good. And then if we give it an integer, so this is going to turn 4 into a float, so it'll be 4.0, right? There we go. And then, so what if we float in 4? Well, that's fine, so it's going to make 4.0 again. Good. And then what if we put like a bunch of zeros? I don't know, trying to break this thing. Yeah, should be fine, 4.1, cool. And then just the only thing is with floats, Python, the way it represents it in code, binaries gets a little weird sometimes. Like this, you would expect it to be 0.01, but it's going to be 0.0, or actually 0.1, sorry, and then 0.09. It's just a tiny bit off. I think we've been saying that this is beyond the scope of the course, why this really happens. I think it said you'll learn more about this in, 2150. So yeah, don't worry about that right now, but yeah. Be aware of that if you ever see like in your code somewhere like it's tiny bit off. Yeah, that's why. So the next thing on our list, I'm skipping over len real quick because I actually already wrote up the code and I didn't do that, so I'll come back. So yeah, so type is just going to return the type of a value. So if we put 5 in there, it's going to give us back int, I believe. Yes, cool. And if we put in sheep is a string, right? So we should get str. Yep. And then if we put in 5.5, 5 is a float, so we should get float. Good. And then if I made this little puzzle, see if you pause the video, figure out what it's going to be. And so, you give it a go. So I think it's going to be str, because if we take all this and we just put it into str, it should be str. There we go. Cool. What do I mean by it returns the type? Like I said, it's going to return 5, and see right here to print it out. Sorry, the type of 5, which is int. So what does it mean when you return something? So I think this is a good place to discuss this. So if you might have this on your computer somewhere. If you type in Python, I think it's Python command line, it'll come up with this thing. Do not worry about this at all for the test. It's just trivia. So let's see. When I put something in here like type, it's going to return it. So if I just put type, say 4, that's going to return int. So even though it's just kind of floating in space right here, it did return int. But if I put this in here in my code, I just say 5 or something like that. Whoops, that is not type. That is type. If I do that, then yeah, it's just gonna kind of take this value, return it, but just throw it at the wall. But yeah, if you were in like command line over here, it would return it there. And the same thing, say type print type 4. I don't know if that makes any sense. This is because I remembered it easier that way when I just thought, oh yeah, if I just put in the command line, that's what it's going to be returning there. So that's what I mean by return. But again, do not worry about that at all. You don't have to worry about the command line, any about that. Okay. Now we're going to learn about len, which finds the length of strings. So if we give len a let's see, how many characters is this string going to be? So let's see, 1, 2, 3, 4, 5. Oh, that's good. That's convenient. All right, so this should print out 5 right there. Cool. Yeah, because the length of this string is 5. So it goes to len 5. Great. Cool. So then let's try pizza. How many letters is pizza? Do you think? Let's see. It's 5. Cool. And also with this work, if we put like 5 spaces in here, 1, 2, 3, 4, 5. That should be 5 too. Yeah. Cool. So it's just the number of characters or whatever in a string. You don't have to know this for the test yet. I just thought it'd be cool to mention here. So len does more than just strings. It also does lists too. So you'll learn this eventually. This is called a list. And so there's 5 items in this list, so it's going to print out 5. Yeah, cool. I like 5 today. So we covered all of this stuff. Now we're moving on to Python operators. So let's start with this one, minus. So minus is only subtraction in Python. You just subtracts 2 numbers. That's it. So we're going to need 0 here. Cool. And then plus. So plus is actually 2 things in Python. It can actually add 2 numbers or floats or whatever together. Or it can concatenate 2 strings together. So 5.5 plus 5, that should give us 10. And then we just so we know, print 5.5 plus 5.5. What is that? 11? Yeah, cool. And then, so then this should stick these 2 hellos together. So yeah, just kind of smack them together. There we go. If you want to put a space in there, you just like put a space right there, and we'd have a little space. And then, so what you can't do is print a string plus an integer, because this is going to give you an error saying, oh, it has to be a string, not an integer. So in order to fix this, you would just put a little quotes around there. It should be fine. Should be fine. So yeah, we saw hello 5 right there. You could also do str5. Just learned. Yeah, works too. All right. And then similar, you can't do plus a float here. He has to be a string. So we should fix that. There we go. And then on to this asterisk right here, and that's going to be multiplication. So 5 times 5 is 24 or 25. And then you can also multiply strings. Say I want this to print out times 5 times. Okay, so hello, 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 hello. Yeah, it's 5. Cool. Well, take a look at this real quick. Well, this is going to fail. Can you figure out why? So Python's actually going to follow the order of operations. It's going to say, all right, I'm going to make this hello, 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 hello. I'm going to add 1. What? I can't add integers to can't concatenate integers to strings like we learned up here. So yeah, if we run this, it's going to get mad at me and say, hey, you can't, do that. It has to be a string. So in order to do this, we could just put parentheses around here. And now it's going to say, oh, I'm going to print hello. What is this? 6 times. Cool. So yeah, so we have 6 hellos in there. Good. All right, so then we have this dividing thing, and I just want to show you here that all combinations, if you have floats or integers, if you have integer over integer, integer over float, float over integer, or float over float, it's all going to give the same thing, 0.8, which is a float. And it actually clearly states in this little list here, make sure that you know that this is a float, not an int right there. So I'm gonna come back to this one right here, but so this is basically dividing, except we're gonna round down every single time. Or you can think of it as floor division, I think it's called. So, or also integer division if you're coming from Java. So let's see. So this is gonna calculate this, and then it's gonna round it down. And this works the same for double zero. So these should both be 0. Yeah. So there we go. If we were to switch the numbers around, 5 divided by 4, that's 1 point something, so it's going to be 1. Yeah, we got 1 right there. Good. I'm going to come back to this one called modulo operator, and this is going to calculate the remainder of two numbers. So if we have, see, we have 10 and 2 right here. So 10 is divisible by 2, so it's going to be 0. Yes, 0 right there. And then, so what's for 3? So let's see, 3, 6, 9. It leaves 1 left over, so we should have a 1 right here. There we go. But I was just playing around with this right here. I found if you make this number anything that's bigger than 2 over here, so like 3. Oh wait, hold on. Something just went wrong with my recording. All right. So yeah, if you put anything that's bigger than over here, with 3 or anything, it's gonna be 2. And so what it did is it tried to divide by this, and it wasn't divisible by that, and what was left over is 2. So here I get 2. There you go. And the modulo is actually super useful in computer science, so if you haven't already figured that out. If you want to find if something is divisible by something, you can say like, so you want to say like 10 divisible by 2. And so if that's going to equal 0, that means they're divisible. So this should be true right there. This 10 is divisible by 2, so the modulo is 0. So the last thing is our exponential right here. So it's just 2 asterisks. So 5 to the second power is 25. So there we go. And let's see. I just like to play this one, make really, really big numbers. I don't know. Does anyone else do that in their spare time? Well, the only ones that you're allowed to use within the print statement with concatenation and multiplying and it's going to be this, the plus and the times. If you try to divide strings, that doesn't make any sense. If you try to exponential strings, modulo strings, or subtract strings, yeah, you're going to get an error because it doesn't make any sense. That's why we went over this. So when we divide that, it's going to give us, it's going to print out 2.0, which is, crap, wrong one. It's going to print out 2.0, this is a float. That's not just going to be 2. So, and also plus works on strings. You can't subtract strings, and you can, yeah, you can multiply a string by an integer, but you can't multiply 2 strings. That makes sense. Yeah. If I run over here, it's going to say, all right, I want to print out hot dog number of times. That doesn't make any sense. See, let me try that. Yeah, what are you talking about? So, yeah. All right, this concept right here is pretty easy. So we have a variable x equals 5, and we want to add 1 to it. So, so we could do x equals x plus 1, and then so we print out x. That's going to be 6, right? So, yeah, 6. So this is a little shortcut way to do this. Instead of writing this, you just write x plus equals 1. That should work. 6. We can also add, more than that. We want to add 5 to it. That's fine. We can also divide and then equals it. So say we do times equals 5. So that's going to equal 25. So basically what we did right there is we said x equals x times 5. So now x is now 25. Yeah, they have these for all of them. Like you can use it with exponential. It's gonna make x that now. I can also say use the modulo, and whoops, modulo equals. It's not x is 0 because 5 is equal to 5, so it's gonna be 0. Okay. So next we have logic, which is and or right here. So let's say we're making a Boolean variable, so this is gonna be either true or false, and so. This is actually going to return a Boolean. You can also put this in an if statement or something, which we'll get to. So if we have this and right here, this means this whole thing is going to be true if both of these are true. So print this out. That's going to be true. If we make even one of these false, though, false, then that's going to make it false. And if obviously if they're both false, then it's going to be false. So then there's a or. So or says this is going to be true if even one of these is true. So if I make this false right here, remember in Python these are capital, and if you're coming from Java those are lowercase. But yeah, so it's going to still be true even though one of them is false. But if we make them both false, then it's going to be false. Yeah, false. So remember with and it wants both of them to be true, and then with or it wants at least one of them to be true. Anything doesn't have to be 2, we can expand this out. So let's see, if I make one of these true. So let's see, what's gonna happen? So this is false or false, so this is gonna be false. So we have false or false here, that's gonna be false. Then we have true or false, so that's gonna be true. So you can also go the other way and make true go that way. Yeah, this is gonna be true. Yep. All right, now for a tricky one. All right, so we have true or false over here. I just took the last one and I put parentheses around each side. We're gonna change this or to an and. So what's that gonna do? So this side's going to be true, right? Because true or false. This side's going to be false, and you can't have a false with and for it to be true. So it's going to be false. There we go. So instead of having just true right here, we can also put things with these comparators right here. So we can say like, what something is true? So 5 is greater than 2, right? And then let's see, this is I'm going to get rid of this real quick. And then or false. So this can be true, and then the same as saying true or false. So it's going to be true. Cool. So yeah, this is less than or equals. This is equals. Remember, this is very different. So let me just go over here. Let's see. 5 equals 5. So this is going to be true, right? So this is the same thing as just writing true right there, right? But it's comparing these two things. So that's going to put out true, So yeah. This is very different from saying 5 equals 5, because equals is when you're saying like x equals something, so you're setting something equal to something. But this is you're checking if they are equal. And this is not equal, and then so if I say like c 5 is not equal to 5, that should be false, right? False, yeah. And greater than or equal to and greater than, yeah, I'm assuming you know that. All right, so assignment, what we just talked about. Yeah, we're moving on to this next section now. So let's see. So we're going to have something over on the left-hand side. So you just have a variable, x. Then we're going to put the equal sign. And then it's going to equal something. So if we have x equals 5, we print out x, then, it's going to be 5. And, you'd have these spaces here, but it makes it look nicer. But, yeah, that's proper syntax, too. And obviously this works too. We're saying y equals 2x, and so x is 5, so that's y is going to equal 5, and then 5 right there, so around 5, yeah. I don't actually remember seeing this, but I'm assuming this means that with the value in type, so we have the value is going to be 5, and the type is going to be int. So we can print out, let's see, print x, and we can print the type of x, and we're going to have 5 and an int. Whoops, wrong one. Yeah, 5 int. Yeah, but if you learn something different in class, go by that. Yeah. Right, so we're going to get into functions soon, but right here it's talking about local versus global scope. This one's a little tricky. So we have x equals 5 here, and then we have this function defined here in this little block of code that's saying, all right, so whenever we run the my function, I'm gonna put x this local variable x equal to this, and that's all I'm going to do. And then, so what we did is we set x equals 5 here, and then we defined the function here. So we actually ran the function here. So if we put this print statement up here, we know for a fact it's going to be 5 because we haven't even run the function yet. So yeah, 5. But what if we put that print statement after there? What do you think is going to happen? So it's actually still going to be 5 because out here this is a global 5, but this x is a x inside my functions. This is my functions x, but not the global x. So it's still going to be 5. And even if we passed the value into there, say this takes a input. Actually, no, can't use that. That's a keyword. I want to call it pizza. All right. So say it's taking an input, so we're going to pass x into the function. So that's actually still not going to work. Yeah. So, and don't worry about this now, but this will be a little bit different when we learn strings. But yeah, not for this test. Don't worry. What if I come in here and I say global x? Now I'm saying all x's are this x because, well, hold on. I tripped up there. So this is saying that all the x that I'm referring to here is referring to this outside x over here. But this does not mean that this x is going to be this x because that if we're going to do that, we'd have to say global x again. So this basically is telling this function, okay, when I set x equal to 0, I want you to actually change this one, not just make up your own x and just do that. So let's see. So right here we have two functions, my function and my function 2. And this was going to change the global x to this, I don't know, whatever that is. What is that? 10 million? I don't know. It's too late. Let's see. So I'm gonna take this out because this doesn't really matter right now. So we have a global x, and this is setting this equal to this. And so take a look at each line. Make sure. So we have x equal 5. We're defining my function, and then my function is going to change this x to this, and then my function 2 is going to do nothing because it's going to set its own x to the 0, and it's not going to do anything. So this x here is going to equal this one. So if we run that, we'll see that. Now be careful. If I take this print statement and I move it up here before this, so what is x going to be? So x actually just going to be 5, right? Yes, the reason it's 5 is we define the functions here, but we never actually ran them. So this is where they run. So now all the x's after this line are going to be those are going to be this one. But yeah, we didn't even you can just like basically even ignore these right there. Like that's all we did. So yeah. All right, so I'm in a little tricky situation right here. So I said that I added a little parameter right here. So this function is going to take in something called y. So when we pass in x here, so now I'm saying, okay, now wherever I see y, I'm gonna deal with this 5 value right here. Well, I don't see any y, so whatever. So it's not gonna do anything. I mean, I could like say y equals whatever, and still not gonna do anything. But the global x, I'm still gonna change this global x. So that's see, it's gonna be that 10 million thing there. Yeah. We can't do say x right here because this so it has a parameter called x, and it's also using the global x. So it's not going to know which x is dealing with here, the local x or the global x. So you're actually going to get an error that's going to tell you that. So it's like, hey, you named this a parameter and a global. We can't do that. So yeah. All right, now we're going to talk about literals. So literal is literally that. It's something that is just how do I explain? Yeah, so literal is just kind of an expression that's just what it says it is. There's no variables in it. I think it's actually like the opposite of literal is variable, but I'm not sure. But yeah, so if we go over to the command line I was showing you earlier, if I type in integer literal, it's gonna print that out right there. When you set x equal to something, you could set it equal to y if you had a variable y or something. But if you just want to say what x is, you put a literal in there. So so we're literal for integer, so you just type in the number. And then floating point, yeah, we just add some decimals in there, fine. And then so yeah, stumbling over my words there. So we have this condition here. So x is going to be true, right? Because 5 is greater than 2. But if we don't want to put like some kind of thing it has to check here, if we just want to make x true, we just write true in order to keep the capital T right there. Yeah, so x is going to be true. So I guess you can kind of think of them like constants. So keep in mind if I'm horribly wrong on a 9:52 on a Monday night, go with whatever you learned in lecture. So definitely. All right, now we have all kinds of strings. So we went over this a little bit earlier. So you can use single quotes, you can use double quotes, you can use triple quotes, triple double quotes, and then yeah, you can use these escape sequences, which I'll show you in a second. Yeah, here's all the things from that list right there. So single is going to work, double is going to work, triple is going to work. So these are all that's going to be there. What these escape sequences are going to do, well, I'll get back to that. So yeah, if you look right here, this is the output. It's going to be single, double. It's, it's what you're putting in. So how do we get these quotes inside here? Because if we just type these in, so Python's going to go through. See, I'm getting like red flags. So it's going through. Okay, I'm starting the string, and then I just stopped. Okay, I guess this is like some kind of variable or something. Oh, no, now we're in string mode again. So how do you prevent that? So you just put a backslash for those, and it's going to escape those out of there. So now you can put quotes within your quotes, and they will work. Another way to do this is if you just switch it up on it. So if you put double quotes here, then you can actually get rid of these, and it'll work. This Python knows that everything. I'm not going to stop this string until I get another double quote. So I'm going to ignore that one. I'm going to ignore that one. Oh, double quotes. So we're going to stop. So yeah, there we go. And we can also put triple quotes there. Yeah, whatever. Let me try triple single. Whatever's going to happen. I think this should be fine. Yep, that works too. Yeah, so just either switch it up on it or use those escape sequences. Another thing, escape sequence. I'm not sure if you've learned this from the first test, but you can put like backslash n as like a new line, or like a let's see, I'm gonna put this over here, like a tab, like a backslash t or something. Yeah, made a new line right there, and then it made it. I can't really see it very well, but I made a tab, I think. If you want to learn more about escape sequences, you can go online and find all these different things you can play with. So yeah. All right, now on to functions. What even is a function? Like what's the point of it? So let's say you just want to put these put lines out. Say my name is and you're gonna say Sean, and you're gonna say pizza, and pizza Sean. You're just gonna change it up. But see, you have to write print my name is a whole bunch of times. So it might be a more efficient way and a lot of less typing if you just put it in kind of like a box that you could just use. So yeah, so if we make a function here called name, I'm going to pass in something called a variable called name, and I'm just going to print out my name is, and I'm going to concatenate it with name, and hopefully name is a string. So let's see. So I'm going to say Sean and pizza, and then pizza Sean. So it should be the same. Yeah, same output right there. So a lot less typing. So right there. So basically, what I think of functions are in Python is just like a box of code that I could just like run that box, and it's just wonderful. Alright, so when you define a function, you use the keyword def, and then you put whatever the name of your function is, followed by whatever your arguments are in these quotes, and then a colon. So what the heck does that all that mean? All right, so we have def. You must have def, and then you're gonna put the name of your function. So I mean, you can name this anything you want, really. Sort of. Let's see. See how you're using print right here? I'm pretty sure this is kind of similar to just making a function called print that you're using. So let's make our own print function. Say instead of wanting to write print out, you want to make your own where you just say just p. So this is the same as printing right here because all you did was you passed the string in right there, and then that's gonna print that out right there. So yeah, so let's type in there. So yeah, basically what I'm saying is you're making your like a custom function right here, just like how you're using print and everything. It's like your own personal function that you made. Then we have the def keyword, then we have the whatever we're calling our function, and then so this is the parameter, and some people get confused with this. So or sorry, not parameter, argument. Yes, argument. So yeah, say we have you can call it anything in the world. I'm gonna call it x, and basically it's gonna take this x, and then wherever it sees it in the function, it's going to use whatever value that is. So if I say let's see, name 9 or something, and it's gonna say my name. Oh, whoops. You see my error. So you cannot concatenate a integer with a string. So I'm gonna put this in quotes. All right, so now we're good. Yeah, my name is 9. Cool. So that's a weird name. But yeah, so it says here we invoke it with the name and then the argument values, but when you define it, you have the list. So what does that mean? So when you define it, you just name a variable here. If you have multiple, you can say x comma y, and then I'm going to say c plus y here. So then when you have this, you have to put 2 arguments in here right here. So then let's see 9 comma 10, and so then now it's going to say, all right, so I'm going to run name. So I'm going to come in a name. I'm going to print out my name is, and then x. So what was x? X is 9. And then what was y? Y was 10. So then there we go. My name is 910. Cool name. All right, now we have the infamous return statement. So what does return even mean? So, we go in here, we just type 5. So 5 is just going to return 5. Just going to throw 5 up in the air, do something with it, or whatever you call it to do with it. So if you say like, so how is it different from print? So if you print 5, it looks like it's doing the same thing. But let's try let's say print 5. So what is this going to do? So it's just going to go in here. It's going to evaluate the inside. So it's going to print out 5, but it's going to print your print statement of 5. And print 5 doesn't return anything. It does an action. So it's actually going to give you none right there. If that was confusing, don't worry. I'm going to explain it a lot better right here. So let's make a function called give me 5. Whoops. Yeah, and it's just going to return 5. So well, see, what does that do if we just run give me 5? So yeah, we ran it. It doesn't have any arguments. We just ran without any arguments. So if we just run that, it's kind of what the heck? I don't see anything. So actually, this return 5. So this basically you can think of as it became 5 right here. But it didn't do anything. It's just like typing 5 here. It's not gonna do anything. It's just gonna throw 5 at the wall and then not spit anything out. So if you want to print that out, show it on the console. So we actually have to print out this give me 5. And there we go. It's gonna print out 5 right there. It says right. Let's see, return what it does, and including that it ends the function. So yeah, remember if you have stuff after the return statement, it's not really gonna, it's never really gonna print out. So see, I returned 5 here, but then so that's the function's over. Like it stops. It keeps going. Move on with your life. So this yay isn't actually ever gonna print. So yeah, it's not gonna work. But I don't really like the way this is designed here. But so to be aware, it's not always ending the function. So if we have if 5 is greater than 10, then we're going to return 6, and then we're going to end the function. Don't worry about this. But 5 isn't greater than 10, so this doesn't work. So we're going to keep going. All right, so we're going to print out yay. So yay is going to print out, and then we're going to return 5, which is going to go here and print out 5. So yeah, so we have yay 5. Cool. Just to reiterate, if you haven't returned something, you can basically think of it as it's like replacing this sort of. Depending on, you can have like, return, say, X or whatever, and it's going to be different each time. But like, whatever you're returning here is going to basically be stick right here, and it's going to be, the same outputs, 5, and if I go up to the original 5, yeah, I think you get it. All right, so we have creation and conclusion of local scope next. So, as I was saying before, when you have a variable inside the function, it's going to be different from when it's outside the function. This is f1's y. F1's version of y. So when you define this, this y is only going to exist inside this function. So this y and this y and this y are all different y's. This is f1's y, and this is f2's y, and this is y's y. So or the global y. Sorry. So if I say global here, global y, then this y is actually going to be the same as this y. This y is still its own y, and then if I put global here too. Then all the y's are going to be the same y. So yeah. So on the test with these local and global scope questions, sometimes they'll give you a lot of tricky things. Where like we're printing out y here, and then we're running functions. And all right, so I'm going to zoom out here and see if you can figure out what this is going to output. I don't know if you can see it. I'm going to zoom in a little bit. So you can pause the video, give it a shot. All right, and this is the answer. So let's go through and figure out why it's that. So the way to do these questions is you basically pretend that you are the computer and go through and figure out what each thing is. All right, so y equals 5. So y is now 5. Okay, so now we're going to print out y. So this is going to be, let's put our answer down here. So this is going to be 5 first. And then, all right. So then, let's see. So now we're defining function 1, y equals 5. Great, good to know, but that doesn't change y. All right, so now print out y. Oh, well, y is still 5, so let's go back down here. 5. Okay. And then, let's see. So now we have function 2 to put in our brain 2, and we have y equals 6, and our local y. Oh, yeah, local variable y is return the y. All right, so good to know. Doesn't change y. Keep going on. All right, then we have function 3. It's going to change the global y. It's going to change it to equal 1. All right, good to know. Still didn't change anything. All right, so now we're going to run function 1. All right, so run this code. Local y equals 5. Oh, well, that didn't change anything. Okay, cool. Good. So y equals 5. Print y. All right, so y is still 5 because y still has not changed yet. So put 5 there. And then let's see. Y equals whatever f2 returns. All right, so what does f2 return? So it's going to return y. Y is a local, so it's going to be y equals 6. So y is now 6. So put 6 there. Because yeah, then after we print right there. So that's where we're going to print out 6. And then so now we're going to run function 3. Okay, so now we're going to change the global y to 1. Okay, so y is now 1. All right, and so now we're going to print y. So we're going to put 1 there. So we have 5, 5, 5, 6, 1. That's what we got. So yeah, so just basically go through each line and figure out what's going on. Sometimes you'll like this one, like they'll put a little sneaky print statement in here, and it say this will be like 50 or something. And so yeah, there's going to be a 50 in there somewhere, and it's going to be right there. And so this isn't going to happen until we run this function right here, and then there's a print inside of there. So when it runs that code, so basically just take each line, go through, and say like, all right, what is happening? I defined a function that doesn't do anything. Okay, now print. Now what am I printing? Like just go through like a computer, do each line, and you should be good. And again, why we like functions, because you have basically boxes of code that do things, and yeah. So it allows you to kind of black box functions of your code, as you'll learn more in Java. So say we have so like x equals 5 or something up here, and then we have to do this really long like differential equation, super hard math thing, and we have to do this a lot. So instead of like doing all this like super numerical code stuff, basically we can just put it all in here and say now that we've got this code working, we've tested it, we know it works. Now we can put our minds at ease and now instead of doing all that math, we can just say do super hard math x, and then it's gonna work. So this kind of works as like a little functioning magical little box. Just does the code, and you don't even have to think about it anymore. It's great until it errors, and then you have to go in here and figure out what's wrong. But yeah. And lastly, we have these conditionals. So we have definition with if, elif, and else. So what do these even do? Let's say we're going to print out I want pizza, and yeah, this works. See, I want pizza. But say we don't always want to print out I want pizza, because like what if we say let's say time equals, and then we're gonna say it's midnight, so 12. Say we don't want it to have pizza past 9 o'clock. It's kind of recording messed up again. I'm not sure where it cut out, but let's see. Get a Chrome extension for this, so it's not always do this. All right. So yeah, I'm gonna say if it's before 9, then I'm gonna print out that I want pizza. So I'm not sure if I put this in for, but 7 says I want pizza. If it's after 12, I'm gonna print out this alternate message, because before we were just doing nothing, but we wanna tell them that it's too late. So we get it's too late right there. Let's say if it's say it's after 9 o'clock, but the pizza's really good. You're still gonna want pizza, right? So let's see. Let's say pizza quality equals really good. Okay. So let's say if this happens, we want this to happen. So we can actually put an or statement here. Say or let's see, pizza quality equals I don't know, not type fast. I'm gonna solve this by doing that, because then it's gonna say I want pizza even though it's 12. But let's say we want to do something different. We want to say I really want pizza because that pizza is really good. So I'm gonna say else if now so it's after 9, so it's not gonna run this part because it's 12. But the pizza quality is really good, so it's gonna run this one right here. So let's give this one a shot. Oh, whoops. Yeah, excuse me. I wrote some Java code here. It's actually elif in that Python. Okay, so run that. I'm saying I really want pizza. All right, so good. But be careful, because say it's 5 o'clock, and pizza's really good. It's actually just going to run this code because it's going to run these in sequential order. Just because if the time is 9, then I'm going to print I want pizza, and then I'm done. So yeah, it's going to run that. So yeah, it's going to say I want pizza. But if it is after 9, just say it's 10. And then, so this one's actually going to fail. That's going to run this one. It's going to be really good. We go pizza. And then, say this is something else. I don't know, bad pizza. And then, I'm just going to say it's too late for pizza. I don't want the pizza. Remember, it's if and then some kind of Boolean expression that or returns some kind of Boolean. And then also elif, not else if that's Java. And also there, remember your colons. Yeah, remember to indent right here. And yeah. Hopefully that makes sense. So yeah, that is everything on here. Yeah, if some of this seems horribly wrong, it probably is because I'm 10 o'clock at Monday night here. But yeah, being sure to go along with whatever you learned in lecture if it's different from this. But yeah, that's a review of everything you've done. I highly suggest practicing coding on paper because it's very different from coding on here because you can't get those errors when you do a little typo. So yeah, good luck.